When most people hear the term machine learning, they picture a single, unified digital brain, a master algorithm solving every problem the exact same way. But the reality is highly fragmented. Under the hood, artificial intelligence is a collection of very different specialized tools, each built for a specific type of problem. If you match the wrong tool to a problem, the system fails. It's like trying to teach someone how to swim by making them sit through a classroom lecture. The approach doesn't match the environment. To understand how these systems actually operate, we have to look at how computers learn in the first place, which closely mirrors the way humans learn. This is the spectrum of feedback. We categorize the three main types of machine learning based on where they sit on this line, defined by exactly how much human guidance they require to function. The way a system is built to learn determines exactly what it can and cannot do for us. To see why, we have to look at each flavor on this spectrum individually. We start at the maximum feedback end of the spectrum, with supervised learning. This approach is like a student learning math with a teacher leaning over their shoulder, actively correcting every single homework problem. In this model, the machine is fed massive amounts of training data already evaluated by humans. Every piece of information comes with a definitive correct answer attached. We call this labeled data. The correct answer, the label, is the prerequisite for this specific type of learning. Look at an email spam filter. By studying thousands of these exact pairs, the email and its corresponding label, the system mathematically decodes the underlying rules of what makes a message malicious. Once it processes enough examples, the system can look at brand new, unseen emails and accurately assign the correct labels entirely on its own. While supervised learning is highly accurate, it has a human bottleneck. If humans cannot explicitly label the correct answer first, the machine cannot learn it. Moving down the spectrum to zero direct feedback, we find unsupervised learning. Imagine a shopper independently noticing that all shoe stores are grouped on a mall's third floor without ever seeing a directory or map. In this model, there are no labels, no correct answers, and no human hints provided to the machine. The machine is fed raw, unorganized data, like the points on this plot, and is tasked with sifting through the noise to find hidden structures entirely on its own. Streaming platforms use this process, called clustering, to analyze raw viewer data and group similar data points together. The algorithm groups viewers into distinct types, like documentary lovers, without a human ever defining those categories. Unsupervised learning allows us to discover relationships in the world that humans wouldn't even know to look for, revealing mathematical truths free from human bias. Finally, we reach the far end of the spectrum, reinforcement learning. This mirrors a toddler learning to walk through pure trial and physical error, falling down and adjusting until it works. The difference here is that there are no static datasets to study. Instead, the AI is placed directly into an active, responsive environment. This creates a constant feedback loop. The system takes an action and receives immediate feedback, a reward or a penalty. This trial and error allowed AI to master games like chess. It played millions of matches, chasing the reward of a win and favoring moves that led to it. In the physical world, a robot vacuum maps your floor plan using the exact same logic. It makes repeated physical attempts, absorbing tiny data penalties every time it collides with furniture until it maps an efficient route. Reinforcement learning represents true experiential learning. These machines master complex environments not by being handed the right answer, but by repeatedly surviving the wrong ones. Modern automation relies on the precise matching of a specific data problem to one of these three learning flavors. Each flavor has distinct environmental needs. Supervised learning relies on explicit labels. Unsupervised learning requires raw, unorganized patterns. And reinforcement learning demands an active environment to navigate. The most advanced systems you interact with today rarely pick just one flavor. They use a combination of all three, working in tandem to make sense of the world. Which brings us to the recommendation engine on your favorite shopping or streaming app. Think about how it groups your habits, tracks your exact clicks, and processes the labels on the items you buy. Based on that data, which of the three learning flavors do you think is actually powering that recommendation? Drop your theory in the comments below.